back row again, so I'm starting the back row. Okay, we'll start with Cecilia if you don't mind. Cecilia, we've looked at this type of question quite a bit with this one. It's going to be 0 over 0, so you'll get to do that one. What's a good second step to try after that, please? Difference of cubes, very good. So what's the numerator going to turn into? Okay, good. All right, Brad, you get the easy one. What do I do with the denominator, please? Okay.
2 divided by x minus 6.
Right on. And you have to do that just so that something will do what? What's the next step down, please? Yeah, and the nice thing about this number, we want to get rid of the 0 over 0. If you step a 2 in, 2 minus 2 is 0. If you step a 2 in there, 2 minus 2 is 0. That's the idea there, right? So I'm going to write that out as equals limit. X approaches 2 of x squared plus 2x plus 4 all over 2. All right, Caleb, what do I do next?
I just sub the 2 in from here.
Perfect, go ahead.
4 plus 4 plus 4 on the top, and then all over 2.
So that should equal 6, is that right?
Oh, yeah.
So what this tells me, okay guys, for those who are a little whispering, stay with me here please. So what this tells me is that as x goes towards 2, y goes towards 6. That's really what we're saying here. Okay? So what I'm going to do here is I want to go over to a graph to show you what I actually mean. Okay, so what I did is I used this my lovely program, which we're going to use today, called Desmos here, and I guess I can hide this one. Okay, and so here's my graph. This is the graph of x cubed minus 8 over 2x minus 4. Isn't it beautiful? So what they're saying is as x approaches 2, if you take a look here, you see 1.94, 5.82, all that. We're getting closer and closer and closer. You know, so once it gets exactly to 2, it says undefined. Okay, because there would be a hole in there. That's what it would be. But if you take a look, as you're very close to 2.006, it's 6.018. 2.04 is 6.21. It's going to be very close to 6. All right. But again, so you're seeing it's just a regular parabola is what that turns into, right, for that. Right. Let's go into this next example. Does that make sense, what I'm saying there? Okay. All right. Jason, up to you in front, please. What do we do next with this one? After the top sounds good to me. Go ahead.
So it's x minus 2, bracket x minus 2, and bracket x is 3.
Okay, there's two things I can do with this question now. Any idea, Trace, what one of those two things are? 1 second.
You can times it by like the square root of
Fair enough. Right, you can rationalize this if you want to. All right, and this is probably, in this case, maybe the easier way to do it. Now, Teresa, what is that going to do for us? Like, why did you decide to do that? Yeah. Yeah, the square roots are going to disappear, right? And then that x minus 2 in the top is going to cross the x minus 2 in the bottom. What's the other way we could have solved this one? Yeah.
Change the x minus 2 into root x minus 2 root x plus 2.
No, that will not work, unfortunately. Because you have to think, that's what that means.
Yeah.
You can't just decomp that, because imagine it's like 5, right? Let's use 6, so that works better. Okay? For the 1/2. That's the same as 4 to the 1/2, which is 2. If you say then 6 to the 1/2 minus 2 to the 1/2, that's not equal to 2. And somebody can confirm that on their calculator, hopefully for me. Right? It doesn't.
That would be like the top on x minus 2, right?
Yeah. I misunderstood, right? So you're going to change this one into?
Yeah, so on the top there's x.
Oh, okay, so you're changing this one into this?
Yeah.
Sorry, I misunderstood. After all that, okay? Yeah, that would work as well, too. There's a third thing that we learned yesterday from Elster.
You can set the square root of x minus 2 to b, and then b squared would equal x.
Right on. So you can use substitution as well, too. So there's many different ways to do this. I like this way, though, since Teresa said it. So I'm going to continue from here. Chris, can you finish off this one for me? Give me the next step.
Right, so then you would like, because the square roots multiply, it'd just be x minus 2 on the bottom, and then it'd be x times square root of x minus 2. And then with that, you cancel out the
Yeah,
x minus
very
2.
good, excellent, okay? Now, the same thing would have worked out the same way. You're doing, I like the way you spread it apart, now that I understood what you actually said. When you get rid of the square roots, you would have crossed out one square root and just been left with one on the top, which is the same thing we would have had here. So this equals limit, x approaches 2, x plus 3, and x minus 2. All right, you, what's the next step, please?
Equal to 0.
Yeah, well, equals 0, that's right, we're just subbing the 2 and it equals 0. So this is going to equal 2 plus 3 root of 2 minus 2, which equals 0. Okay? Now, please be brave and ask if there's questions, okay? Because this is an awesome graph. I don't remember, oh, sorry, go ahead.
Isn't it like not equal?
Okay, 0 is okay. 0 is an all right number. 0 divided by 0 we don't like, okay? But 0 is an all right answer. Someone was asking me about that from the homework. They said every answer was 0. Well, I don't think every answer was 0, but it's okay if there is the occasional 0 for an answer. Just you can't get like 2 over 0 or 0 over 0, doesn't work. Okay, let's go back to this equation. Anyone remember what a square root equation looks like? The graph of one. Okay, numbers? That's okay, let's talk about domain. What's the possible domain for a square root equation? What's the domain? What possible x values have to go in a square root? Oh my goodness. Positive, thank you, good. So does it make sense then that 2 is, so it's going to give us an answer of 0 here because that's the smallest number that can go in. Right? 3 can go in, 4 can go in, a million can go in. 1 doesn't work, 0 doesn't work, and anything on that side, okay? So when I actually graph this, which I'm going to do right now for you, hopefully. You're going to have this, the limit's going to, oops, I can move this over, hopefully. That's what the problem is, that's what it's going to look like. And if I take a look at the points here, we're getting big in a hurry, coming down this way, and it says 2 and undefined. Right, so there would be like an asymptote or something like that. This graph in the program isn't perfect at asymptotes and things like that, but I like it because it gives you the coordinates if you're looking for them. Okay? Has anyone here used Desmos other than me? Awesome. Okay. This is wonderful to check your work with, especially as we get further in this course and there's more graphing. Okay, it's really good to check things out and make sure if it makes sense. Okay. Close those two and use this later on. All right. I have a Desmos app on my phone. My wife thinks it's weird, but whatever. I like it. Okay, let's go through some homework questions. Let's start with 5B. Limit x approaches 0. X all over 1 plus. All right, this is the one that made me angry when I looked at this one. And I don't often get angry, okay? But I got angry at this one. Nicole, what's the first step to evaluating every limit that we do? Yeah, so we're subbing whatever x is approaching. What does x approach here? 0, so the numerator is?
0.
The denominator is?
0.
Ah, the denominator is 2. So unfortunately, you just want a 0 over 2, it just equals 0. Grrr.
It's 1 plus x squared.
Whatever, it doesn't really matter.
Either way, it's good.
It still equals 0. Sorry about that. Thank you. Okay, but it still equals 0.
That's really funny.
Oh, yeah, I'm sorry, thank you for fixing it. If this probably should have been 1 minus, and I made a typo, but either way, if you get one in your test that works out to 0 over something, leave it, that's an okay answer, okay? Okay? So that one's the easy way for me to solve that one, all right? I am going to do C, D, and 7 here. 5C. Says limits. X approaches 1. The square root of x plus 8 minus 3. All right, this looks very, very similar to one we did in class yesterday. Okay, it's a little different maybe, but it's pretty close. Luke, I'm even going to tell you, I'm even going to give you the first step. You got to use substitution here. I guess you rationalized. Did you guys substitute or did you rationalize? Everyone substitute? Okay, Luke, you got to substitute. What's the messy thing we got to get rid of here?
The root of x plus 8.
Good. So I'm going to say we're going to set L for Luke equals root of x plus 8. Now, the other thing we need to do here, I'm going to rearrange that equation and isolate x. Why am I going to rearrange that equation to isolate x?
So then you can get to x.
Yeah, the x and the bottom you need to, because you can't have two variables in the same equation, right? An L and an x you don't want. Okay, so I'm going to rearrange this. I'm going to say, well, Derek, I'm going to pick on you. If I want to isolate x, what's my first step, please?
If you square both of them, you get with the root.
Good, so L squared equals x plus 8. Very good. Yes, L squared minus 8. Okay, does everyone understand why I need to isolate x? Okay, just because there's a plain x in the bottom, you can't have two variables there, right? So now we're going to substitute twice. All right, Tori, would you be kind enough to substitute those back in for me, please?
Okay, so you're gonna have b minus 3 all over b squared minus 8 minus 1, which goes to b squared minus 9. And then you can do a difference of squares on the bottom. Or L, right, sorry, I used b in my example, I'm sorry.
We're all excited there, all right?
I'm sorry, I'm sorry.
It's okay.
I'm reading off of my own.
Okay, so terms of the limit. Hold on right there, I'm gonna let someone else get a chance here. All right. This is looking good. I'm feeling actually quite good about this question right now. Matthew, can you please continue to do the next step here?
I'm a pass.
No problem, that's all right. I'll try. I'll help you out. Feel that something, the denominator looks like something you can change.
Oh, can you make that L minus 3 L plus 3?
Perfect. Hang on.
And you cross this.
Right on. Okay, and that's the thing, right? You have to think, hey, there's a way always to simplify these, right? So that crosses. You get limit. This approaches 1 over L plus 3. Okay, things are looking so good. Like, I'm very happy right now. It takes a lot to make me happy. No, it doesn't. Good algebra is all that makes me happy, okay? Nobody laughs. It's true, though. Good algebra does make me happy. Hannah, what do we do now, please, if anything?
So,
Right on. Okay, so I'm going to say, but L equals, what L equals root of x plus 8. So, limit x approaches 1 over root of equals 1/6. Is that right? I'm going to take a step back and just make sure that we balance there. The next one I think I want to solve by rationalizing, if that's okay. Because this one I did substitution, the next one I do by rationalizing, just so we see both ways. I only wanted H. H is an awesome one. There's so many good ones. It looks so scary. No one's frightened of H?
You can do it.
No, too late. So easy for everyone to back. Whatever. It looks scarier, doesn't it? All right. Let's move on to 5D. Okay, this one I'm going to solve with the complex conjugate.
Oh, could you have done the complex conjugate for C as well?
Yes. Some whoever had the first steps that they want to do by substitution. All right, James, I would like you to be brave. Could you tell me what to multiply that by, please? okay?
I'll do the same thing.
Oh, excuse me, right on. Now, I'm doing this both ways just because you'll be responsible for questions that you have to do them both ways, so. Now, one thing to note, the only sign that changes is the sign between the two square roots. Okay, right? The first one doesn't change to x minus 3, right? Like that stays the same for both of them. Right, Alistair, what do you do now, please?
X plus 3 over x. Square root plus 4 plus 4.
All right, Emma, why are we happy at this stage? I'll write the next line, then you tell me why we're happy. And why are we happy? That cancels X. Which is equal to 1 over 2 root 3. Root 3 plus root 3 is 2 root 3. And that should give you the same answer if you did it by substitution. Okay. Is this making sense for most people here? Like, the unfortunate truth of math is practice makes perfect, right? That's why I gave you 50 questions to do here. Right? By trying them out, this actually makes you smarter in math. It's a fact. All right, here comes number 7. Are you ready for this one? And we're not ready yet. Are you ready? All right. Haley, before we start this question, okay, what does that equation sort of look like to you if you squint? Yeah, that totally looks to me like, I didn't want to go further and call it instantaneous rate of change, because like that's like your h goes to 0, okay? That is your instantaneous rate of change difference quotient. That's what that is. Okay, so Haley, with that now known, what should I do to solve that then? Yeah, right? So what I'm going to do is I'm going to say limit delta x approaches 0, a times, and this is going to be a big one. Is everyone down the left forward because this is going to be a biggie. And when this is a biggie. Plus b Okay. Now, I think people freaked out in this question. I hope you don't mind using the word freak out, because it's tying two things together, which is what we did earlier in the course, plus what we did in this part. Okay, but that's all it is. Okay, this shouldn't be that scary. All right, Austin, following time for you, please. What is a times x plus delta x all squared? Okay.
So you get a and then brackets x squared plus delta x squared plus 2x delta x.
Right.
A squared x delta x.
That's right.
Also,
No, a isn't squared, a stays the same. So it's x squared plus 2x delta x plus delta x squared. I think that's what you said, but you had them moved around, right? But I think that's what you said. Yeah, it is gonna be a 2x. All right, I'll do the rest here. Plus bx plus b delta x plus c. Now, if you think back to earlier in this unit when we did this, this is like the messy middle step. The middle step for these are messy. The end is going to turn into, what was it, 2ax plus b, right? So it's going to turn to something beautiful at the end here, right? Noah, what do I do next? Expand and cancel. I'll do that for you. So expand notice. Delta x approaches 0. Ax squared plus 2a x delta x plus a delta x squared plus bx okay, this is looking awesome. I'm loving this algebra. Okay. Bailey, who I know is also loving this algebra. What cancels now, if anything?
Because you use ax squared, bx's.
Okay. Unfortunately, what's going to cancel for these, as you guys will find, whatever is negative here should cancel from the first set of numbers, okay? And if it doesn't, that means you made an algebra mistake somewhere. All right, what am I left with then? Can you just read it out, please? Go ahead.
2ax delta x plus
Yeah.
b delta x squared b delta x multiplied by delta x. Yeah. 2ax plus a
Is that it?
plus b.
I'm going to slow down here just to make sure it's caught up. Okay. So what we did is we canceled and rewrote. Cecilia, and we got through the whole class already. This is wonderful. Why are we happy, Cecilia, right now? All the delta x's cancel. So this turns into limit. Delta x approaches 0, 2ax plus a delta x plus b. Brad, what is my final answer? Right? Close. There's 2ax stays here too because there's no, it's only the delta x that crosses out. And because delta x turns to 0, the x stays the same. So this is going to be 2ax plus b. This is a very powerful proof that we will use a little later in the course, but I want you guys to struggle with it for one night. Okay? This is just algebra. And hopefully once you saw that you just had to sub this in, I'm confident everyone can do it from here, right? But it's that first step, you're saying, do I do it? What do I do? You have to sort of see, like Haley said, that it seems a different quotient from before. And once you have that, it should be fine. Okay? I'm going to pause the video and then we're going to start today's lesson. 23 minutes.